Hello everyone, today I'm going to talk to you about AC, short for alternating current, and discuss its properties. To understand AC, we first need to look at direct current, or DC for short. The behavior of DC is much like its name, direct. This means that a constant current flows in one direction with a constant voltage. Therefore, elements in a DC circuit receive constant power. A battery is an example of a DC source, as it provides a voltage in one direction. As shown in the simple diagram, when the circuit is closed, the current flows in one direction continuously. Please note that the diagram follows conventional current flow. However, with alternating current, the direction of the current flow changes direction in accordance with its frequency. This frequency can be described by how many times it alternates per second. Due to the current changing direction, the voltage also varies with time, which means the power delivered to components in a circuit vary with time also. An example of an AC circuit is shown here, and as you can see, the current direction changes with respect to time. Since the current and voltage are alternating, we can plot the current or the voltage with respect to time, and come up with a sinusoidal graph like this. Above the x-axis is current flow in one direction, and below is in the other direction. The distance between the peak of the wave and zero is called the amplitude. Find the distance between the top peak and the bottom peak, and you get the peak-to-peak value. The time taken for the wave to complete one cycle is called the period, and the amount of cycles in 1 second is called the frequency, which is measured in hertz. Here in Australia, the frequency of AC in a power point is around 50 hertz, which means that there are 50 voltage cycles per second. The waveform plot shown can be described mathematically by a formula. The formula used to plot AC is in the form AM sine omega t plus or minus theta, where AM is the amplitude, omega, which looks like a lowercase w, is the angular velocity, which is 2 pi divided by the period. T is the time, and theta is the phase. The phase is the offset of the x-axis and proves useful when comparing voltage and current when they are out of phase. Additionally, an AC current can have a DC offset, which is an offset of the y-axis, and is denoted by the formula added or being taken away from a number n. Unfortunately, that's all for today, as I am out of time. I'd like to thank you for watching, and hopefully you learn a bit about what AC is and some of its properties.